Okay. Uh, Hello. I'm Dr. Samad Noeiaghdam. I'm PhD of Applied Mathematics, Associate Professor of Baykal School of Physics, Irkutsk National Research Technical University, and Senior Researcher of Source State University. The topic of lecture is industrial mathematics and its applications. So at first I want to talk about mathematics and about pure mathematics, applied mathematics, industrial mathematics, and also here I talk about some mathematical models related to engineering and real life problems. I think it would be interesting for uh, students. Uh, At first, before starting to talk about these topics, at first I would like to thank the organization committee of this Olympiad and also all the students and researchers and professors for joining us. I forgot to say about this. Uh, okay, if you want to talk about mathematics, mathematics is one of the oldest and the most fundamental sciences that mathematicians use mathematical theories, computational techniques, algorithms, and the latest computer technology to solve the problems arising from various fields such as economics, engineering, business, pure and social sciences, and many other fields. The work of mathematicians falls into two broad classes, that is pure or theoretical mathematics and applied mathematics. However, these two classes are nearly overlapping and no sharply defined. At first, I want to describe about pure mathematics. The pure mathematicians advance mathematical knowledge by developing new principles and recognizing previously unknown relationships between exciting principles of mathematics. Although these workers seek to improve basic knowledge without necessarily considering its practical use, such pure and abstract knowledge has been instrumental in producing or achieving various scientific and engineering advancements. Many of the theoretical mathematicians are employed at university and spending their time in teaching and in conducting research activities. In fact, they enjoy deep devotion to mathematics in theoretical proofs and establishment of new principles. But about applied mathematics, that applied mathematicians, on the other hand, use theories and techniques such as mathematical modeling and computational methods to formulate and to solve practical problems in business, administration, engineering, physical and social sciences, and many other fields. For example, they may analyze the most efficient way to schedule airline routes between cities or the effect and safety of new drugs, the aerodynamic characteristics of an experimental automobile, and the cost effectiveness of alternative manufacturing process, and many other topics. Also applied mathematicians working in industrial research and development may develop or enhance mathematical methods when solving a difficult problem. But about industrial mathematics, that is our main topic here. The industrial mathematics and its application is a fast-growing field within the mathematical sciences, particularly in the domain of applied mathematics. just as the term information technology has replaced computer science. So the term industrial mathematics is about to replace applied mathematics. The meaning of industrial mathematics is mathematical modeling and scientific computing of industrial problems. Since it's most applicable mathematics, it deals with the problems posed by different industries, which are of organizational, technical, and economic nature. Furthermore, industrial mathematics is characterized by the origin of the problems appearing from industry, research and development, finances, communications, and other fields. Naturally, industrial mathematics comprises from a variety of mathematical disciplines, such as partial differential equations or dynamical systems, control theory, probability and statistics, discrete mathematics, and also other fields related to industrial mathematics. The common feature running throughout this enterprise is the goal of gaining better understanding of industrial models and processes throughout mathematical ideas and computations. But if we talk about objectives of industrial mathematics, the main objectives of industrial mathematics are to understand the real-world industrial problems originally posed on a non-mathematical language, to transform them into appropriate mathematical framework, to find possible solutions of these problems by suitable methods, which may be analytical or numerical in nature, to test the accuracy, validity, and reliability of obtained solutions, and finally to interpret the realizations in term of original real-world industrial problems. It was my descriptions about mathematics and especially about industrial mathematics. But here I have some mathematical models that I want to describe about these models. Maybe this model will be interesting for students. The first model is mathematical model of computer viruses. We know that when we want to provide a mathematical model, it's different from other models. It's not in some special forms, some special models that maybe you can see in, I don't know, engineering or other majors. The mathematical models is in the form of mathematical relations and in this form, in the form of system of differential equations, or maybe system of partial differential equations, or integral equations, or other forms related to mathematics. This model is the mathematical model of computer viruses that here is based on susceptible, infected, and recovered computers. That we can solve this model by using numerical or semi-analytical methods, and we can forecast the number of, for example, infected computers at a special time. And we can forecast about, for example, recovered computers or sustainable computers in a special time. So next model is the model of HIV infection for CD4 plus T cells. But again, it's in form of nonlinear system of differential equations that we can apply numerical or semi-analytical methods for solving this model. And it has some real applications in medical sciences, and also it's based on uninfected and infected cells that we can forecast about uninfected and infected cells in HIV infection. Also here we have some other characters and parameters related to this model. Next model is the model of load leveling problem. That using this model, we can forecast the battery load in energy storage system. That it's really applicable, especially in power engineering. That is in the form of maybe first kind or second kind linear or non-linear water integral equations, or maybe system of integral equations. That here we have discontinuous kernels. We can solve this model again by using different methods, and we can forecast. We can forecast for special time, for example, for 24 hours or maybe for 48 hours. And also we can combine our method with big data and deep learning algorithms to forecast the results. Next model is the model of energy supply demand system. That is really applicable model to supply and demand of energy. Again, it's a nonlinear system of ordinary differential equations. We can solve by different methods. Also, we have the fractional form of this model, and using this model, we can save energy in special area, maybe, or maybe in a special city or country. And it's really applicable to save energy. Next model is the model of reverse osmosis system. That is, it has some applications in ecology engineering and water engineering, and using reverse osmosis. Reverse osmosis is a water purification process for drinking water that we can modelize in form of partial differential equations in this form, equation 5, and we can solve by using several methods, and we can again we can forecast about some parameters that we have here. And next is the application of image analysis. That we have some different methods and some different algorithms to image denoising and smoothing. That we have the image denoising and generally image analysis has applications in medical sciences. That we can, using some techniques and some algorithms and also some special software, so we can provide some clear image by using denoising techniques and smoothing techniques. We can provide some clear and high quality photos that it can help to medical sciences. Also here here I have an example for smoothing that is after 5 steps and after 10 steps. That again using some algorithms we can provide these photos, and also it's based on applied mathematics because we have some special formulas that we should solve. These formulas by using some accurate methods to provide accurate numerical results. If we have numerical accurate results, we can provide better image and better results in the algorithms. And also we have so many mathematical models in different fields. Maybe to forecast the weather, or in banking risk, in signal analysis, and also recently we talk about fuzzy mathematics, that we can combine the fuzzy mathematics with applied mathematics, and we can provide new mathematical models based on fuzzy arithmetic. But here I know that here only these topics and knowing these topics would be enough for students. Here, the last topic I want to talk about our industrial mathematics laboratory in Irkutsk, in Irkutsk National Research Technical University. That in Irkutsk recently we established an industrial mathematics laboratory with some researchers from Irkutsk National Research Technical University and also especially my dear friend Professor Denis Sidorov, member of Russian Academy of Science, and also other professors from other universities. I can say that we arranged different national and international teams to work on various mathematical problems. And here I show some of these problems in different fields of engineering and real life. In our laboratory, we have different mathematical courses related to industrial mathematics and image analysis, signal analysis, mathematical modeling, powering systems, and many other fields. I know about this Olympiad, and I know that this Olympiad is maybe it's your first step to participate in the international arena. But I know that the students who participate in international Olympiads, they are not ordinary people. They are like students who shine all over the world if they find their way. Yeah? And I know that maybe you have very good and accurate ideas in various scientific fields that need to be presented in special research groups and become scientific research. So from here, I want to invite all students to join our industrial mathematics laboratory. With the help of great Russian and international professors, we have established this laboratory so talented and motivated students can progress throughout our scientific and spiritual support. You can be a member of our lab, and you can be a member of our research groups, and with the help and guidance of great international professors, you will be able to join different mathematical courses or maybe write various research articles and publish them in prestigious journals around the world. Okay, thank you. Thank you for your attention.
Mr. Samad, thank you very much.
Thank you. Thank you.
Thank you for your lecture. Thank you that you found time to give this speech. Thank you very much.